Your notes. The first thing you see in your notes is these are the steps to solving equations. And there's two different processes depending on whether you have two radical signs or one. What's a radical sign? Next to this word radical, above this word radical, somebody's messed with my pen. Okay, as I was saying, this is a radical sign. Please write that next to the word radical. What's another thing that we might call this symbol? It is also a square root sign. A radical includes the different roots that we're going to be learning about in the next 2 weeks. Square roots, cubed roots, fourth roots, fifth roots. All of those different roots all have a symbol that looks like this that's called a radical sign. Today we are focusing on the square root. And step number 1 says when the equation has two radicals, we have to move one to the other side of the equation. Please look at example number 1. In example number 1, do you have two radicals? If you have two radicals, I need one on the left-hand side of the equal sign and one on the right-hand side of the equal sign. Now, in this problem's already been solved out for you. And what we're going to do over here on this other side is write down the reasons or the steps to get here. This is called a two-column proof. Is it obvious why it's called two columns? And it is a proof because we're going to write down the mathematical steps, the reasons behind what we do. Now, what happened between step A and step B? What happened to this part right here? If you add this whole thing on both sides, this cancels out and this is what you get. And so that is called the addition property of equality. We added that to both sides so that there would be a square root on both sides. Now, between step B and C, what happened? You see that the square root sign is gone? What do you do to get rid of a square root sign? Square both sides. So to get from here to here, you square both sides. And then it's just simply solving. Steps C, D, and E is solving like you would solve any linear equation. So what happened to the x to go from a 3x to a 2x? What happened to the 14 to go from a 15 to a 14? And so that is actually called the subtraction property of equality. It's called the property of equality because we did it on both sides of the equal sign. We did the subtraction, and so that's going to cancel out, and that's going to cancel out. And then what happened to the 2? Here we have a 2, and in the next step we don't. And so that would be called the division property of equality. And so here we have an answer, maybe. You don't know for sure if you have a true answer until you check it. When you check it, you're checking this answer. This is the original problem, and in place of x, they put a 7 and checked it out. And what does this mean? It checked out, it's true. That means that the x minus 7 is a solution. It's not that the 0 is a solution. The x minus 7 is a solution because that was substituted in and it made a true answer. And so there's no extraneous solutions in this because it checked out. Example number 2, they have all the steps, but we have to do all the work here. And so if you have 2 radical signs, you have 2 square root signs, you need 1 on each side. So I'm going to have to move 1, so I'm going to subtract this one from both sides. And that'll give me 2x minus 3 equals negative x minus 6. Do I have a radical on both sides of the equal sign? Now I'm ready to get rid of the square root sign, the radical sign. How am I going to get rid of that sign? Tells me right there. Now, look where I put my parentheses here. Do you see that the parentheses in front of the 2? I am squaring all of this, including the 2. What is 2 squared? And then the square and the square root cancel each other out. This is what some people missed on the test. Negative times negative is what? Positive. And so this would be positive x minus 6 because negative times negative is a positive. Negative 6 squared is not negative 36. I don't care what your calculator told you. The calculator told you that because you put it in wrong. That was one of the things people missed on the test. And so now what am I going to do with the 4? 4x minus 12 equals x minus 6. Now I need to combine like terms. I need to subtract x from both sides. And I need to add 12 to both sides so that I can combine like terms and get 3x, 12's cancel, x's cancel. And then divide by 3, and what's my answer? Maybe. What do I have to do? On every single problem, you have to check the answer. So, we need to check the answer. To check the answer, you go back and write down the original problem, and in place of the x, you put the 2. Well, what is 2 times the square root of negative 1? That's an I, so this would be 2 times I. What's the square root of negative 4? And that's where they got the 4i. Is 4i equal to 0? And so, is there a solution? There's not. And so what does that mean that x minus 2 is? When you plug it back in to check it, assuming you did all your steps on your checking correctly, if it doesn't check out, then it's an extraneous answer. Now, example number 3, do we have 2 radical signs? How many radical signs do we have? Just 1. And so that on your note paper is on the first page of your note paper, that's the second steps. And it says, step number 1, under this, where it says 1 radical, step number 1 says, isolate the radical term. Isolate the square root. Is this on one side of the equal sign all by itself? Yes, that's what isolate means. And so here, what we're going to put is given equation. The equation that we start with is the problem somebody gave us. So to go from this step to that step, I need to square both sides of the equation to cancel out the square root. So I need to square both sides of the equation. Then what happened to my 17? Here I have a 17, here I don't. What happened to it? And that's called the addition property of equality, or combine like terms. Here I have a 7x, here I don't have a 7. What happened to my 7? And so this is called the division property of equality. And then you have to check. You have to check this answer. You plug the 6 back into the original problem and you calculate it out. And if it is true, that doesn't mean the answer is 5. It means this x minus 6 was a solution. The number you plugged in was a true solution. Step number 1. This has to be by itself. If you have only one radical sign, it has to be by itself. How am I going to get it by itself? What am I going to do with the 1? And so this is going to be 3x minus 8 equals 2. I isolated the radical. This square root sign is on one side of the equal sign by itself. Now I need to get rid of it. The square and the square root cancel each other out. What am I going to do with the 8? So this would be 3x equals 12. Then I'm going to divide by the 3. And then I'm going to cancel that out, and x equals 4, maybe. What do I have to do to know for sure? You have to check your answers. How do you check your answers? You write the original problem down, and in place of the x, I'm going to put this 4 that I just figured out. So what's 3 times 4 minus 8? So that means 2 plus 1 equals 3. True or false? That doesn't mean my answer is 3. That means the solution is this x minus 4 that I checked out. And is there an extraneous solution? Is that your last example problem? Problem number 4 on your homework paper. How many radical signs does it have? Okay, it has 2 radical signs. If you have 2 radical signs, you need to get one radical sign on each side of the equal sign. I need to have this one over here. I need to add this one to both sides so that I will have a radical sign on each side of the equal sign. Then I need to get rid of the radical signs. In order to get rid of the radical signs, you need to square both sides. And so then this is going to be 2x plus 10. Now you see this 2 out in front? It gets squared also. You are squaring everything, including the 2. Now I am just combining like terms, and so what am I going to do with this 2 over here? 10 equals 2x. Divide by 2. X equals 5, maybe. Because what does this side of your paper say? What are we checking? We're checking to see if x equals 5 is a true solution. So, I need to 2 plus 10 minus 2 square roots in place of the x. I go back to the original problem, and in place of the x, I substitute in the 5s. And so this would be 10 plus 10 Is that true? Is the square root of 20 minus 2 square roots of 15? 5. Is that equal to 0? Well, this one is in simplified form. This one's not. So I need to go down here on my paper somewhere and do a birthday cake. Do you remember a birthday cake? The reason we do a birthday cake is to find a pair. This is equal to 2 square roots of 5. If you have the exact same radical subtracting, is that equal to 0? This is true. You can also put this in your, right here in this step, you can put this in your calculator. If you remember to close that automatic parentheses, you can put this part right here in your calculator, and it will come out to equal 0 if you want to try it out. Now, what do I put down here where it says solution? What's the solution? The x equals 5 that I checked out. What do I put down here where it says extraneous?